Hello again and welcome back. In our last lesson, we conducted our experiment, plotted our gas volume against Celsius temperature, and extrapolated our line backward to find absolute zero at minus 273 degrees Celsius. But why haven't we formally stated Charles's law yet? Take a close look at our graph. In physics, for two variables to be directly proportional, the line must pass directly through the origin, 0, 0. As you can see, at 0 degrees Celsius, the volume is V0, not 0. Because this line intercepts the vertical axis above 0, we cannot say that volume is directly proportional to Celsius temperature. To fix this mathematical limitation, science established a brand new temperature scale starting at the lowest possible thermal point in the universe, absolute zero. We set minus 273 degrees Celsius as our absolute start line, defining it as 0 Kelvin. If we step forward from 0 Kelvin, by the time we reach 0 degrees Celsius, we have moved 273 degrees. We then call this 273 Kelvin. If we step forward again up to temperature little t degrees Celsius, we then call this 273 plus little t. This gives us our foundational conversion formula. Thermodynamic temperature, capital T in Kelvin, equals Celsius temperature, little t, plus 273. Now, here is the masterstroke. What if we shift our vertical volume axis to the left, moving it directly over the 0 Kelvin point? Watch what happens. By relocating our origin to 0 Kelvin and 0 volume, our experimental line now passes straight through the absolute origin. 0, 0. Now, volume capital V and absolute temperature, capital T, reach 0 simultaneously. We have finally unlocked the true direct proportionality. Volume is directly proportional to thermodynamic temperature. With our absolute baseline established, we can now formally state Charles's law. At constant pressure, the volume of a given mass of gas is directly proportional to its thermodynamic temperature. Mathematically, V is proportional to capital T, which means V divided by T equals a constant, K. For any change in state, we write this as V1 over T1 equals V2 over T2. Before we wrap up, let's practice two quick conversions to make sure you are 100% comfortable switching between temperature scales. Example 1. Convert 15 degrees Celsius to Kelvin. We use capital T equals little t plus 273. Substitute 15 for T. 15 plus 273 gives us 288 Kelvin. Example 2. Convert 300 Kelvin to Celsius. Rearranging our formula, capital T equals little t plus 273 gives little t equals capital T minus 273. Substitute 300 for capital T. 300 minus 273 gives us 27 degrees Celsius. Simple, elegant, and practical. Thank you so much for joining us today. If this lesson made Charles's law crystal clear for you, we would love to have you in our learning family. Please take a quick moment to subscribe to the Udimking Education Foundation YouTube channel. By subscribing and turning on notifications, you will gain full, unlimited access to our entire library of step-by-step physics and science video lectures, designed to help you excel effortlessly. Hit that subscribe button below, share this video with your classmates, and let's keep unlocking the secrets of science together. See you in our next lesson.
Udimking Education Foundation. Building confidence, ending examination malpractice for a better tomorrow.
We are building a better tomorrow.
Join us in shaping futures through integrity and education.